Hey guys, this is your next edition of what we're learning in my class. Today's video is called I Feel the Need for speed. We've been talking about forces and motion, and speed is going to be a characteristic that we can tell that an object is in motion. You know that an object is in motion because the distance between it and a reference point is changing. Well, it's going to be able to change in different ways based on the forces, and you guys have been working on that. So speed is just simply going to be a characteristic to let us know that an object is in motion. So, what is speed? Let's look at that first. The definition of speed is the distance that an object travels divided by the time that it takes to travel, or speed equals distance divided by time. And you can see my little illustration that I have here. So we've got a little bit of math to learn today, but this is not going to be hard math. So let's take a look. Speed and distance and time are all mathematically connected. So as long as you know two of those figures, you can always find the third. And the way I do it is I have a triangle, S, D, and T. If I'm looking for speed, I simply cover up the S, and I know that it's distance divided by time. Looking for distance, I cover the D, it's speed times time, and if I'm looking for time, it's distance divided by speed. So you make one triangle, S in the left corner, D in the top corner, T in the right corner. Cover the one that you're looking for, and it tells you how to mathematically deal with the other two. So let's do some practice problems. This says, use the equation above to answer the following questions. Well, you're just simply going to use speed equals distance divided by time, and you're going to use your triangle in order to figure it out. At this point, I need for you to pause the video exactly on these four problems and work them in your EN. Be sure to remember your units of measure and try to use your triangle. Here's the work. Go ahead and pause it to check your work. You'll notice that I've underlined specific measurements. I've given you the units of measure, and I've also showed you how I worked the individual problem. When you get down to problem 4, I circled the S because the unit of measure for speed here is seconds, but it gives you time in minutes. So you first have to convert and then change it over and do your distance equals speed times time. All right, the last bit, how do I know if all I'm looking at is a graph? What can a graph tell me about the speed of an object? Well, based on the graph, on the y-axis, we're always going to have distance, and on the x-axis, we're always going to have time. So distance divided by time. Now, if you've got a fast object, that object is covering a lot of distance in a very short period of time, and we end up with a pretty steep slope. So that's the graph that you see on the left. A steep slope indicates a very fast speed. I'm covering a lot of distance in a very little period of time. Well, what happens if I have a slower speed? I've got a smaller amount of distance covered in a longer amount of time. So I have a gradual slope, which is going to be a slower speed. Well, we know that some objects just don't have motion, or they stop from being in motion. And what does that graph look like? Well, that's a horizontal line. No distance is being gained from the reference point or being lost from the reference point. It's simply staying still, time continues on, so we have no slope. And that's a wrap.